Everyone, welcome back to my channel Explore with Aditi Vyas. In today's video, I'm going to discuss about part 1 of your organic chemistry, that is your nomenclature of organic compound as well as unique nature of carbon atom and isomerism. Here I'm going to provide you handwritten notes of this chapter with practice questions. But before that, if you are new to my channel, please subscribe to it. So let's start with the introduction part. Organic simply deals with the carbon atoms, all right. And if we talk about the sources of organic compound, then these are plants, animal, coal, wood, etc. Okay, then come to the application of organic chemistry. So it is extremely useful in our daily life. Okay, the soap, shampoo, perfume, the food we eat, all come from our organic compounds. This is your introduction part basically. Now come to the unique nature of carbon atom, which is your first topic of organic chemistry. So carbon atom show tetravalency, which means carbon has 4 valence electron. So it is known as tetravalent, and it can neither lose or gain electron to attain octet. It forms covalent bond. All right. Whenever you have carbon with some bromine, chlorine, and something else, then you have to put hydrogen to make it valence. All right, then come to the catenation, the property of atom to form bond with itself. Okay, so carbon shows this property very well. Carbon make long chains like this, propane, butane, etc. So here it make long chains with itself and give rise to the single last structure or chain is known as catenation. All right, three types of catenation, which involve single, double, and triple bond, which are covalent. So this is your straight, branched, and cyclic chain. These kind of chains are your straight chain. All right, and these kind of chain are your branched chain, and these are your cyclic or closed. The structure can itself say that it is closed. All right, and it these all chains like straight chain, branched chain, and closed chain can be prepared by single, double, and triple bond. More than 5 million organic compounds are known today. More than 5 million. Okay. Now here I'm going to discuss a little bit about hydrocarbons. So compounds that are made up of only carbon and hydrogen atoms are known as hydrocarbon. Then these hydrocarbons are of two types. One is cyclic and the second one is aliphatic or open. Cyclic are closed ones, aliphatic are open ones. And in case of open ones, we have two types, saturated and unsaturated. Saturated are alkanes having only single bond, while unsaturated are of two type, having maybe have double bond or triple bond. Double bond are alkenes and triple bond are alkyne. All right. In case of closed, it is further three types, cycloalkanes, cycloalkenes, and cycloalkynes. Having single bond in case of cycloalkanes, having double bond in cycloalkenes, and having triple bond in cycloalkynes. Now come to the alkyl group, very, very important. It is obtained by removing one atom of hydrogen from alkane. We have alkane like methane. All right, here we have methane, and when we are going to remove this hydrogen, we have the formula that is CH3, and this is known as methyl. Here we are changing this ane into il and call it alkyl group. The general formula is CnH2n plus 2 is for alkane, and if we are going to remove one hydrogen from it, it means here we are removing, so we have to add only one. Okay, so this is the general formula of alkyl. Then come to the next very important question according to the board is isomerism. So here iso means same. All right, and I'm going to use a trick. Here M stand for molecular formula. All right, whenever you are forgetting this concept, you just have to apply the trick that iso means same, M for molecular formula. So what are isomerism? Having same molecular formula but structural formula is different is known as isomerism. Now look at the example. Here we have butvanine and the second one is butene. both having the same molecular formula, but the structure is different. Here the position of double bond is at 1 carbon, and here the position of double bond is at 2. So what kind of isomerism is this? Position isomerism. All right, the position of double bond are different. Then come to the second example, that is your butane and 2-methyl propane. All right, both having the same formula but having same structural formula. All right, so here we have 4 carbon, simply means butane. Here we also have 4 carbon, but this is your main chain, and that that group or that alkyl group which is not added in your main chain of carbon, we are only going to take the main chain. We can take a chain like this or like this. Okay, we are not going down or upward to contain the main chain, okay, to check the main chain. So here it is a substituent, it is known as substituent, which is not involved in main chain. So it is 1 2 3 chain of carbon, means propane, and having 2-methyl. At the position of 2 we are having a substituent, that is your methyl. Okay, but both of them having same structural same molecular formula but have different structural formula. All right, and this substituent is writing before the chain. Okay, we are writing here 2-methyl then propane. So substituents are for CH3 it is methyl, for C2H5 it is ethyl, and then for chlorine it is chloro, bromo, and fluoro. All right, now come to the next part. Having 1 carbon means meth, having 2 carbons mean eth, 3 stand for prop, 4 for but, 5 for pent. We all know this. Okay, and if we have the 1 bond, then we have to say it is ane. Having double bond means ane, and having triple bond means ane. Okay, so for example, here it is ethane, it is ethene, it is ethine, because of these double bond. Okay, now come to one more example. This is your but1ene and this is your but2ene. We are not starting the counting from here, because whenever we have the double bond or we have the bond, then we are going to give priority to this bond and starting the calculation from here. Now one more confusion, that here we have double bond between 2 and 3. So what we have to write, but3ene or but2ene. So we are going with the small one. So here we are writing but2ene. All right. Now come to the practice question. Here we have the long chain of 7 carbon and having substituent at 3 and 4. So we are going to write about 3,4 dimethyl. We are having 2-methyl na, so we are going to write about dimethyl, and 7 means hept, and there is no double bond or a triple bond, so heptane. Now come to the next practice question, that is this one. Here you can see that we are having 2 substituent. So it's a little bit confused. We are going to little bit confused that from where to start. So here we are going to alphabetically. All right, B comes first from C. So we are going to start the counting from here and not from here. All right, so we are going to write it first, that is 2 bromo, 3 chloro, then butane. All right, and if we having the double bond and substituent, then we are going to give priority to this double bond, and here the name will become 3 bromo prop 1ene. All right, the counting of carbon starting from the double bond, not from the substituent. All right, and look at this structure. If we have such condition, then 1 2 3 at the position 2 we have 2 methyl groups, so we have to write 2,2-dimethyl propane. All right, then come to the functional group, very important. It decide the property of compound, and whenever we are going to give IUPAC name, we have going to give priority to functional group, then bonding, then substituent. Okay. So alcohol having the functional group OH, aldehyde having CHO, ketone is CO, carboxylic acid is COOH. For alcohol we have all, for aldehyde L, ketone on, and for carboxylic acid oic acid. So look at the first example, which is an important example of your alcohol. Here we having the functional group. So we start the counting from that carbon in which the functional group has been attached. So 2 carbons means ethane, and at ethane it is having 1 ol, ethanol. Okay. Look at the second example. We have the long chain of propane, but it have a functional group at 2, so it is propane 2 ol, sorry. All right. Then in case of aldehyde and ketone, many people get confused, but there is no need to be confused. In case of aldehyde, we having C double bond O, but at the end we have H. And in case of ketone, we having chain, then C double bond O, then chain. All right. And one important question, that what is this C double bond O? So this is your carbonyl group. All right. Firstly, look at the example of aldehyde. 1 carbon means methane. At position 1, you have 1 L. Aldehyde, for aldehyde we are using L. So what is this? Methanol. This is your ethane, 2 carbons. Okay. At position 1, you have this double bond with oxygen. So this is your ethanol. All right. Because we are going to start the counting from functional group. All right. And if we talk about aldehyde functional group, this is your functional group C double bond OH. So it is ethanol. Look at the example of ketone having chain both the side, and in the center we have this carbonyl group. So this is what propane 2 on. This is 3 carbon, and at position 2 you have 1 on, which means propion. Okay. Then take the example of butane 2 on. I'm not going to balancing the carbon here. You have to balance it. Then come to the carboxylic acid. Carboxylic acid having C double bond O and OH functional group. Okay. In case of aldehyde, we don't have this oxygen here. So look at the example. Single carbon, methane, 1 oic acid, methanoic acid. There is one more example, that is your, not example, one more concept, that is your ether. Okay. In case of ether, you have the chain and oxygen, then chain. The small one chain is known as oxy, and the long chain is known as ane. All right. For example, here you have CH3, CH2O, CH2, CH3. So this is ethoxy, and this is your ethane. All right. And in case of this is your small chain na? So it is methoxy, and this is your long chain, which means ethane. But here you have to write the common name. Look at this. This is nothing but this is C2H5, which means ethyl. Okay. So you what is the common name of this compound? This is diethyl ether. What is the IUPAC name? This is ethoxyethane. So you have to write the common name in exam. Okay. Here we come to the practice question. In case of such example, you have to firstly detect the functional group, then start the counting from there. Then you have to give priority to double bond, and then you have to give priority to substituent. But we are writing the substituent firstly. So here it is 4,4-dimethyl hex. At position 2, you have double bond ene and 1 oic acid. All right. So come to the next, that is your ester. For ester, we have to give name, that is OH and IL. All right. So from this example, we can say it is methyl ethanol. All right. This is what, this is ethane. And in case of second, this is methyl, 3 chain of carbon, C2, 1 C is here, propanoate. Okay, so this is all about your nomenclature. I hope you all understand it. Thank you for watching.